Exercise 2.29. The coordinates of a point A are 1.8, 3.0 in feet. The y coordinate of point B is 0.6 feet. The vector RAB has the same direction as the unit vector EAV, which is equal to 0.616 in the I direction minus 0.788 in the J direction. What are the components of RAB? Alright, so what I'm going to do is to first solve the exercise ASAP, and then I'm going to explain what was needed for me to solve it. So, of course, I'm going to say what I'm doing. So the first thing that I want to do is to write down the coordinates for the 2 points. So for the point A, I have 1.8, 3.0. For the point B, I just have one coordinate, which is the y coordinate. That means that I do not know bx, 0.6. 0.6. Both of them are in feet, so no worries about the unit system. The vector RAV has the same direction as the unit vector AB. Well, that is actually something that we should already know. For when we're talking about a unit vector, it has always the same direction as the original vector. So they are asking for the components of the vector RAB. Given to me, I don't like to use this nomenclature because I'm not used to it. So I'm going to change it to the same thing, but using like a little hat above the letter. Alright. So I have that the unit vector is equal to 0.616 on the I and 0.788 along the J direction. Alright, so basically what they are asking for me to do is to find px. Why is that? Because by finding all the components or the two coordinates for the 2 points, I just can subtract the final minus the initial, and I'm going to have our final answer. So this is something that I want to tell you guys. For when you're looking for a vector using the coordinates, all you have to do is to subtract the final minus the initial. Alright, so the vector RAV is going to be equal to final bx minus 1.8 on the I direction plus 0.6 minus 3. Final minus initial. Once again, final minus initial. Alright, right there we have it. Now, if you remember, I can say that the unit vector RAV, the unit vector RAV is going to be equal to the vector divided by the magnitude of the vector. But I can say, well, let me write it once completed. Once it's completed, so right here I have bx minus 1.8 plus 0.6 minus 3 divided by the unit vector RAB by the magnitude, sorry, not the unit vector. So I already have this equation. You know, right here you have this, and right here you have this, which is the magnitude, and this, which is the vector. And right here I have the unit vector. So I can say that this is also, sorry, I'm going to write it right here, equal to 0.16 minus 0.788, right? Which is the unit vector. But there is one thing that happens, and is that I only have one equation and two unknowns, which are the px and the magnitude. I don't have the magnitude. So I have to be able to find another equation for me to solve this, right? So if you notice, right here I have one equation, but I actually have two. I can divide this huge equation into just taking into account the I system and the j, I forgot to write down this here, and the j system, the j axis and the I axis. I don't like the word system, sorry. So something is that I can say that minus 0.788 is going to be equal to 0.6 minus 3 divided by the magnitude of RAB, right? I'm just taking into consideration these two, this part, the j-axis part of the equation. Alright, now because of this I can find this incognito, right? So all I have to do is to subtract 0.6, sorry, to subtract 3 from 0.6. So minus 3 is equal to minus 2.4. So right here I have minus 0.788 is equal to minus 2.4 divided by the magnitude of RAV. That means that the magnitude, hence this means therefore, the magnitude of RAV is going to be equal to 2.4, so minus 2.4 divided by minus 0.788 divided by minus 0.788. And right here I have that the magnitude of RAB is equal to 3.0456. All right, I have the magnitude. I assume that this is in feet. Yeah, because we are talking about feet. Now, I already have the magnitude, so I would be able to just take in consideration this other part of the equation, right? So bx minus 1.8 divided by the magnitude of RAB is going to be equal to 0.616. Both of them are along the I direction. And finally, bx is going to be equal to 0.616 multiplied by the magnitude plus 1.8, right? So bx is equal to, this is in answer, this is already stored right here, so I can just write down this 1/6 times answer within parentheses plus 1.8, and finally this is equal to 3.6761. There is one way in which I can know if this is true, and this is by using the calculator. So I'm going to write down the whole equation, which is x, which is my unknown, minus 1.8 divided by the magnitude, which is 3.0456. This is equal to 0.616, and I just have to press shift solve for x. Yes, I want to solve it for x. This number, well, what the calculator does, it's an iteration, so it just tries to find the number that meet this requirement. So what the calculator does is, well, I'm going to try with 1. Okay, this is not true, this is not equal. Okay, I'm going to try with 2, with 3. That's an iteration, sorry. So number that I write down, or that I put right here, it is going to be the first number that the calculator is going to try. So I don't really care about it. It is actually a pretty simple equation. So it could be 100, 1, 1000. So I just can press 5 and whatever. Sorry, I lost the equation. Right here I have it. Shift solve for x. Yep, equal 3.6761. I lost some digits right here. That is why this is not the same result, but this is the most accurate one. And finally, once I have bx, I'm going to write down this here, 3.6761. All I have to do is to subtract final minus initial. So at the end, the vector RAV is going to be equal to 3.6761 minus 1.8 on the I direction plus 0.6 minus 3 along the J direction. 0.6 minus 3, we already did that, so I just have to subtract the answer minus 1.8, and finally the vector RAB is equal to 1.876 on the I direction minus 2.4 on the J direction. This is in feet, sorry. Remember, this final answer should be reasonable. As you can see, this vector is divided by two other vectors, which is the components. The x component, which is directly related to the I direction, should be positive because it is toward the same direction that the positive number for x, the positive numbers for x, right? And the other should be negative because of the same reason, but the other way around. This is the positive numbers for y, and right here I have that this component is towards the opposite direction. All right, so this makes sense. And that's it, guys. This is how you can solve this exercise.